All right. At this moment, I don't see myself ever teaching an online class. It's so much work.
I wouldn't take an online math class.
Huh?
I wouldn't take an online math class.
Yeah, I'm not saying it would never work for anybody, but I had a roommate, and she had this is a long time ago, but she had an online course, and I just watched her go insane with the amount of, no, never.
So like there's just certain courses that really shouldn't be taught.
Yeah, this I agree with. Some of they might work for students, for teachers, but me, I don't see myself doing it. I would go insane. You might be able to pick up on the fact that I like to interact with people. I can't make those go away. All right, so let's take a look at, this is page 186. I'm going to do 10.5 right now, because it builds off of skills we did in 10.4. Well, that's why it's all over the place. Now look at this question right here. Now, obviously, are these like radicals? Are these like?
Yes.
Yes. No, I don't mean, are they like radicals? No, are they like terms? All right. What about these guys?
Yes.
Yes. What about these guys? No, but can I simplify one of them?
Yes.
Yes. What do you do when you simplify this guy?
4 and 3.
Yeah, so I can get square root of 4, square root of 3. What's the square root of 4? 2. Square root of 3, I don't know. So now I see that they are actually like terms. They're like radicals. It's like totally radical. So then, yes.
What page?
186.
Oh, you said it.
186, yeah. So do that first problem right there, number 1. Oh, there it is. All right, thank you. It's almost 2 minutes. All right, so you guys should be done. This is just a like terms problem, right? There's no radicals I can do anything with. So how many rad 5s do I end up with?
-7.
-7 rad 5s. And how many rad 10s? 3 rad 10s. I love that. So just be really careful when you have a coefficient, like that 3 is a coefficient, it doesn't mean cube root of 10. So even make that 3 maybe a little bigger than normal, just like this is a coefficient, not a little tiny 3 that's a cube root. That so sucks. When you do a mistake like that early in your problem, everything else goes crazy. So how would you do number 2?
Record the cube root of 24.
Yes, okay, go ahead. So you can simplify the cube root of 24, so try to do that. Think about cube rootable numbers. And to be honest, I don't think I've said this yet, but remember how in factoring there's a lot of problems with hints in them? I'll bet you anything that it's going to be 3 that I divide into 24, because I'm going to want a 3 left over, so it can be like terms with the other 3 do. So these also have hints in them. 24 is not a hard number, but still, it's kind of nice to realize that. So I want to do 3 times something is 24, and that other thing, I'll bet you anything, is cube rootable. Cube rootable, yes. Just making words up. So I see this hint. The only way this could be like terms is if it ends up with a 3 inside. And 24 is 8 times 3. what's the cube root of 8?
2.
2. So you 2 cube roots of 3 plus 2 cube roots of 3 is 4 cube roots of 3. Is that all right? Is that? Yes? No? Somebody's like, I don't know, man. We haven't done enough of these for me to even tell.
I would-
Yes?
So if you were to break up the inside of a square root,
Yes.
like say like a number 3,
Yes. Good.
the 2 and square root of 24, if you break up the inside, what happens to the outside? What happens to the 2? Does it just carry down?
Yeah, because I really want, let's really focus on this, because this is something that comes up a lot. It's a really good question, and I have, yay. By the way, if anybody needs this, I forgot to ask, there's an updated timeline homework sheet. There's several right here. Okay, so let's just focus on this by itself. That piece of this. Right? What's the operation right now? Multiplication. So it's 2 times whatever this is. Alright, so when I do stuff to this, how would I break up 24 for the square root?
12.
6.
So 12 and 2 is a way to break up 24, but neither 12 nor 2 is square rootable. Right? Do you see what I mean? So there's a lot of different ways to factor a number, but in this case there's only one way, so that, yeah, exactly, 4 and 6, because 4 is square rootable. You want to break it up into a part I can do and a part I can't, and then remarkably enough, the next step is do the part you can do. Well, what happens to the 2? This is the question. It just keeps coming. 2 times, what's the square root of 24? Square root of 4 times square root of 6. What's the square root of 4? 2. So it's 2 times square root of 6, so 4 square root of 6. Let me make that more clear. 4 square root of 6. So it doesn't look like a 4th root. Alright. Is that cool? That's a good question, but that coefficient is multiplying. So anything that comes out of that root 24 piece will multiply by what's in front, because that's what it's doing. So now I know what this piece is. This piece is 4 rad 6. So I got cube root of 6 minus square root of 6 plus 4 rad 6. What's like terms in there? They all have a 6 in them. Yay!
Just the square root.
Yeah, but this is a cube root. So he's all by himself in the world. How many rad 6s do I have? 3. Yeah, negative 1 of them plus 4 of them is 3 of them. Cool? Yes? No? Alright. So what's it take for radicals to be like terms? The inside's got to be the same, and the root's got to be the same. So you can't put those together, because one's a cube root, one's a square root. Now, I don't like when they go immediately to this, so let's see if we can handle this next one. So it's a little bit freakadelic. Tiny, tiny bit. What's the square root of 4? 2. Now, all right, let's focus on this piece right here. Let's talk about this. And actually, let me just do this way, and then we'll do the shortcut later. What did we do with 24? We broke it up into 4 and 6. Why won't this work? Why can't I do the square root of x cubed? Because I can't cut the 3 in half nicely, right? Can I break up x cubed into a part I can do a square root of and the other part? X cubed is x squared times x. So it's just like 4 times 6. It was the part I can do something to, and the other part that just has to be there. So what can I do with this? I can do, let me see if you guys are cool with this. Square root of 4 is 2. Right, that part's easy. So I we got 3 sitting outside times 2. And now let's break this part up. Square root of x squared times square root of x. And if you are doing the homework, you have seen these instructions up here. Assume that all variables represent non-negative, blah, 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 right? What that means is, on those problems, they just don't want you to have to worry about the absolute value stuff. Remember that? The absolute value's got to come in, but now they're saying, okay, there's too much other shit going on. Don't worry about the absolute value stuff. Just focus on getting this stuff done. Was that? So you're going to see that instruction, those instructions, in the later sections in this chapter, so that you don't have to have that extra layer to worry about. So what can I do now? Well, yeah, what's the square root of x squared? X. And what's 3 times 2? 6. So I get 6x rad x minus rad x. Not rad x. Rad x. Now this is what's weird, and I kind of disagree a little tiny bit. Those are not like terms. They just aren't. They really aren't. One has got 6 x rad x's, and the other's got minus 1 rad x. But you will see the book do this. What do they both have in common? Nope, just the first guy's got an x. Right? Square root of x. So you can take that square root of x out. So what you'll see the book write, I'm cool if you stop right here. To be honest, I think this is more correct. But what you'll see the book do is this. Let's take our rad x out.
So if you do this in the test, both of them can be right?
Yes. Which really, now watch this. If I go back, now watch. Is everybody decent with both of those? And that's just taking out the common rad x. Now watch this. I want to show you something from way earlier this semester that we can look at in a little different light. What is 11y cubed minus 6y cubed? 5y cubed. Let me do it this way. Plus, just to make a point. So that, of course, would be what? 17y cubed. Now, I'm going to have somebody tell me that's 17y to the 6th. And I'm going to say, where do you see 17y to the 6th? I don't even see a single y to the 6th. But now watch this. What do they both have? Y cubed. So I can take a y cubed out. This is why it's 17y cubed, because if you took a y cubed out, you would be looking just at the numbers, and that's 17. Is that all right? I mean, some of you guys are like, I didn't have a problem with that, Jeff. But some of you guys do have a problem with that. That's just a little bit different way to look at that. That's why there's no y6s. There are no y6s anywhere. There's a bunch of y cubes. Okay. Yes. Same thing. It would have been minus, and that would have been 5. I just want to make a point when it's plus, people think somehow they just become 6, and that's not correct. I like it. All right, let me give you another one here, because this book didn't give you enough examples. Try this one. Good Lord, Jeff. All right, it's just that kind of day. Oh, what you got? Let's see. Let's do 3 square root of 45 plus 2 square root of 125. I like it. Good. careful about this, is you put that 3 there, times, how are you guys breaking up 45? 9 times 5. And you see, that it's a good idea to start with a smaller number. It's easier to think about it. This one's not that bad of a number, you should know what it is, but I know it's going to have to be a 5 that goes into it, because that's what's going to make it like terms eventually. If you have no idea what the shit I'm talking about, just attack 125 directly. Don't look for any hints. Right? How do I break this one up? Yeah, 25 times 5. So I've just written the same thing, but in a better form. Because what's the square root of 9? Times 3. So I got 9 rad 5s. What's the square root of 25? Times 2. So plus 10 rad 5s is 19 rad 5s. Alright, let's see who still likes me after this. Yeah. You might drive yourself a little crazy now. I kind of made this problem to really let you see the importance of this idea of a hint. What am I going to have to expect to go into 189? I'm going to have to expect 7. It's the only way I can have like terms is if there's a 7 piece to this. Bless you. And 189 divided by 7 is 27. Thank God I did that right in my head. Part of me was like, shit, did I hit 1 by 9? So how am I going to break this up into cube root of 27 times cube root of 7? Bless you.
Thank you.
I'm a 3. Okay. Man. So bad for you guys. Right worse shit. So then I get cube root of 7 plus, what's the cube root of 27? 3. So cube root of 7 plus 3 cube root of 7 is 4 cube roots of 7. Schwab. I like it. So that's the immediate first thing you can do when we learn the whole way to simplify a radical. I like it. So we got that. Okay. So now looking at the rest of 10.5, and then we'll go back and do 10.4. What does it look like is the property to use here? Distributor. So if I distribute this, I can kind of be nice to myself and just write 2 rad 7 times rad 7 minus 2 rad 7 times 2 rad 2. Now, I want to remind you guys about something. There it is. Do me a favor. What is, stay with me now. What is 2x times 3x plus 4?
6x.
Yeah, do you notice how, what do you do with the 2? Well, you put it with the thing you can put it with. I can do 2 times 3, so I do it. I can do x times x, so I do it. This is 6 times x squared because I can't do anything more. So what do I do with the 2? Well, I'll put it with the 3. And then, of course, this is plus 8x, because I can do the 2 times 4, and the x just comes from the right. Now, what the shit's this got to do with the problem we're actually looking at? Well, here, what could I multiply?
7 and 7.
Yeah, because they both have a rad on them. The 2 just kind of comes from the right because it's got nobody to go with. So it's 2 rad 49. We'll do that in a minute. What happens here? What can I put together? almost everything. So I can do 2 times 2, that's 4. And rad 7 times rad 2 is rad,
7.
say it again,
Rad 7.
14. 7 times 2, right? Is that cool? You guys see that? So the rad pieces are like the x parts before. You can combine those. And the coefficients are like the coefficients before. You can put those together.
Oh, because it's multiplication.
Yes.
If it was that addition.
You're distributing, right? We distributed to get to this step. 2 rad 7 times rad 7. I wrote that there and then I did it. 2 rad 7 times 2 rad 2. I wrote that there and then I did it. Do you have to do this step? No, you don't have to. Right? So if you want to, you can do this step, or you can just do the multiplication as you go through. It's just that this radical stuff is a little new. You might want to write it all out for yourself. What's up? You all right? So in this step, this is like 2x times 2x. 2's can go together. This pieces can go together.
Gotcha.
These aren't really unknowns. That's why I was able to actually do something with the numbers inside. Okay. Because I always get students that are like, what do I do with that? Why doesn't it go there? Right? Because you only put the stuff together that you actually are allowed to put together. The other stuff just comes for the ride. I like it. Okay. So do number 6.
So the other one, we don't square the 49?
Oh, sorry. Did I finish that?
Yeah, I was gonna say, couldn't you?
Oh, yeah. Thank you. So what is this? Yeah, sorry. I was so desperately making a point here, I forgot what it is. Yeah, this is 2 times 7, which is, and this is awesome. I'm glad you reminded me of that, because here's another point. Can I do anything else there? Do you understand the person? This might be you. I might have just cut you off from saying this, and you're welcome. It's not 10 rad 14. It's not. Because this is 14 minus 4 of these. The only way it could become 10 rad 14 if this was 14 rad 14. Then I can write how many rad 14s I have total. Are these like terms? No, this is like 14 minus 4x. They're not like terms. They don't both have a number of rad 14s. I can't put these together. If it would have been this, I would have been able to do something. If that would have been 14 rad 14 minus 4 rad 14. Now I can do something. You got 14 of these minus 4 of these. That would be 10 rad 14. But that is not what that is. So this is not like terms. I understand your brain is like, that's 10, come on, just put 10. You just tell your brain, stop trying to mess me up. All right, thank you for that, sorry. So do number 6. And maybe finish it all the way up. You better than me. Not too crazy, right? What do you get here? Cube root of 8. Plus, what do you get here?
5 cube root of 64.
5 cube root of 64. And now you know both of those. You know both of those. What's the cube root of 8? 2. Plus 5 times, what's the cube root of 64? 4. And then I hate it when somebody does all this great, and then you go 7 times 4. I'm like, shit. Right? So I like the look I just got from some of you guys. Like, what? This is 2 plus 20. 22. What happens? I hate that. You get all this hard shit correct, and then the last easy thing is like, oh. let me see if I can, no, that problem's done. I'm gonna try to point out one little thing. If you don't like what I'm saying, you can just, continue to ignore me. At this point, can anybody tell me how many 2's are in 32? Don't say 16, let's think about it. How many 2's multiplied by 32? Anybody? How about 16? How many 2's make 16? Not divided by. So how many 2's do you multiply to make 16? 4. 2 times 2 is 4, times 2 times 2 is another 4, that's 16. So that was 32, 5 2's. One more 2 makes it double 16, you get 32. So that's why I can't do the cube root of 32, because it's got 5 2's in it. I can't cut that in thirds. What am I effectively doing when I multiply it by that? I'm giving it another 2. Now how many 2's are there? 6. Can I cut that in thirds? Yes. What is 6 cut in thirds? 2. So 2 squared is 4. That's why the answer is 4. You see what I'm saying? That's why I was able to do it after I gave it one more factor of 2. It made it be able to be cut in thirds, and that's why I could do it. Did you have to look at that way to do the problem? Obviously not, because we did it. And right now I'm looking at it that way.
If you were to have written that out in the tree form, would it
Yes.
have 6 2's?
Yes. For 64. Yeah, 32's only got 5, and then I give it one more 2 when they distribute that. All right, if you have no idea what I just talked about, after we finish this, you're fine. It's just another way to kind of think about why it happened the way it did. If I ever see too many people understand this, I've got to step in and make it more confusing. What do you guys think about this? Yeah, do it. So this is another example of the basic rules cannot change. I just have radicals inside now. Oh shit. But the FOIL doesn't change. You still do the same thing. Alright, let's see. That shows. We're going to bring that 2 through first. 2 times 8. 2 times 2 rad 3. No. 4 rad 3. 4 rad 3. I could only multiply it by that 3 inside if it itself was inside a radical. So I can't, so it's sort of like 2 times 2x. Do I multiply 2 by x? I don't know what this shit that is, but I can multiply 2 by the 2. So in this case, I can multiply the 2 by the 2, get 4, and the rad 3 comes for the rad. Now we bring the rad 3 through. What's 8 times negative rad 3?
Negative rad 3.
Now, negative 2 rad 9. Both those 3's are inside radicals, so I'm allowed to, both the same root, so I'm allowed to multiply them together. Now real quick, the last 2 problems I've done something kind of silly, but I want to do it a couple times first. Not really silly, it's completely correct. But of course the square root of 3 times the square root of 3 is 3. Isn't the square root of 9 3? Because what does the square root of 3 represent? Half of 3. So if I multiply it by the other half of 3, I'm going to get a freaking whole 3. So somebody help me out. What is the square root What's the square root of 15 times the square root of 15? No thought required.
2.
Square root of 15
15.
times the square root of 15 is 15. Square root of 28 times the square root of 28, 28. I really want this to make sense, because square root of something times the square root of that same thing is the square root of that squared. Don't the square root and square cancel? But to me, I love the idea that it's like those little necklaces with a half a heart you can put with your friend. Oh, right? So half of 3 times another half of 3 makes a whole frickin' 3. Now, do you have to know that? Not really. It just makes some of this quicker. So instead of putting this, I could have just put 3. That's what it's going to become anyway, isn't it? Yeah. So it's a nice little shortcut. It happens often enough to become a really useful shortcut, but if you don't like it, you don't really have to do it. So what can I do here? I got, this is going to become, what's the middle going to become?
Negative.
Oh, shit. Put a plus down. You have minus 4 rad 3. And this is going to be minus 2 times 3. Is that cool? 16 minus 4 rad 3 minus 6, which is 10 minus 4 rad 3. And some of you guys are just not going to be able to resist the urge to make this 6 rad 3. But you will get a bulk of the points for having done the first several steps correctly. I will have to take something off, though, because you're writing something down that's wrong. Ready for that? You guys got that? Go ahead and do number 8. Hopefully some of you guys realize something interesting in the way it's set up. Even if you don't see that, just do it, and you'll see something interesting happen. What do you guys notice? What's square root of 5? 10 square root of 5?
Square root of 5.
5. Minus square root of 10 is equal plus square root of 10. What's the square root of 2 times the square root of 2? 2. What happens to these bad boys? They die. 5 minus 2 is? Oh, that's funkadelic. Now think about it. Root 5 plus root 2 is totally irrational. It's the freaky, it's the decimal never ends, no pattern. Root 5 minus root 2 is also totally irrational. It's a decimal that never ends. You multiply those crazy 2 funky-ass, infinite, irrational numbers and you get 3. I love that shit. Right, it's kind of nice. They complete each other. Can somebody explain to me what it was? That form doesn't look like a difference of squares kind of idea, right? That's why the middle terms cancel. And the middle was the only place there could have been a radical because the outsides complete each other, right? The 5s become a whole 5. The 2s become... So if it is like this, rad something plus rad same thing minus rad same thing, you're going to have the middle scan. You're going to come out with a nice whole number. It's crazy. We're going to use that fact back in section 10.4, which is why I always love that they do 10.4 before we do this. Yeah, there you go. Conjugates. Oh, here they are. Good job, Jeff. Didn't even look there. They are called, this is written by math people, so give us a
They got the conjugate order.
They got the conjugate order, that's right. This is not like conjugate your verbs, so this is a different kind of thing. But let's see. Let's multiply this out. What's rad A times rad A? A. And then I'm going to get minus rad AB plus rad AB. And what's rad b times rad b?
A, B.
B. Rad b times rad b is b. The middle terms cancel, I get a minus b. And just point this out. Guys, what was a up here? What was a? 5. What's b? 2. 5 minus 2 is? Funkadelic. What happens when you multiply conjugates? Good stuff. Highly technical phrase. So what's the conjugate of this? So look, these are conjugates of each other. Exact same radicals, but there's a different sign in the middle. That's it. So what's the conjugate of this? What's the conjugate of this? 2 rad 3 plus rad 6. Bam! What's the conjugate of this? There's a few different ways you can do this one, but yes? Minus rad x. I love it. What's the other way you could have done this? I could have turned this around. Isn't this the same thing as that? And what's this guy's direct conjugate? Rad x plus 5, right? Either way works. They're both true. Just depends on which order you write those two things in. How are we doing? I see some people confused. Maybe you're confused because you're like, it can't be as easy as it sounds like what he's saying. But that's all a conjugate is change a sign in the middle. Then it becomes like a difference of squares pair, where the middle terms, which is the only parts that could be irrational, they die. Right? Kill all the irrational and leave the rational people. Oh, I'm sorry, numbers. And of course, this one, what would this be? Negative rad 13 plus 7. 11. And if you turn around, you can do some similar stuff. I like it. All right. Oh, let me not go there yet. We got to go back to 10.4 for a second. This is where we start getting into division of stuff, and this is where we use this idea. So let's go back to 10.4 now and talk about division of stuff. Okay. Stay with me. Oh, okay. Now, the first couple here are very straightforward. There's nothing really new for the first few. We already know how to do roots of fractions. You just do the top and the bottom. So what's the square root of 16 over t squared?
14.
Technically it would be absolute value, but again, just don't worry about the absolute values here. On a test, you have to worry about absolute values maybe being needed if I don't say assume everything is positive, right? What about this dude here? Oh, sorry, this is page 183, sorry. We went back to 10.4. Good buddy. What's the cube root of 8? 2. Cube root of x cubed? X. Cube root of 27? 3. I like it. Give me a second. I want to check one thing out before I am too far away. Yeah, okay. Alright, I'll do that. Come on. Alright. Now, here's where we start getting maybe a little bit more interested. Why is this one a little bit harder? Yeah, there's a fourth root, but how many x's are there? 5. All right. Well, let's talk about this idea. And I kind of teased this before. I said, the problems are really great when the root matches up with the power inside. They're easy. If there was 8 x's, fourth root of x squared, 8 would be x squared. You just cut it in fours. I can't cut 5 in fours nicely. So what the shit? So we actually did a problem like this a minute ago, but I want to really, really make you realize how there's a shortcut that's almost too beautiful to believe. God, it sounds so weird. No, it's good. So watch this. I can do the square root of a squared, right? What's that? Assume everything's positive, so that's just going to be a. If I ask you what this is, I seemingly can't do that directly. We actually did one like this earlier. But there's like, why can't I do that as easy? Because I put an extra A in there, right? It's an idea of an extra A. Which means the two A's that are in there, I can still do something with them. Now watch this shortcut. So when we had this in the problem earlier, it was the square root of x cubed. We did this a minute ago. And we broke that up as square root of x squared times square root of x, right? Remember that a little while ago? And then that was just x rad x. But now watch this. This is so beautiful. Sorry, I keep saying that. You're all like, none of this is beautiful. The way that we've said division ever since you first learned division applies perfectly here. What's the root understood to be? 2. 2 goes into 3 how many times? Once, with 1 left over. Right? Isn't that how we said it way back? So 2 goes into 3 once with 1 left. Please let that be almost too nice to believe, right? Let's do some more. So what about the 7th root of x to the 16th? 7 goes into 16 twice with 2 left over, done. And let me do that the long way, just so you can see the comparison, right? I'm going to do this the long way. 7 goes into 14. I could break this up as the 7th root of x 14 times the 7th root of x squared. You see how that's the 2 extra x's? 7 goes into 14 twice. So why not just do it more directly, right? Get the same answer that way. Let's do it more directly. That remainder is the extra x's. That's why that shortcut works. Let's do another one. Another one. Let's see. What about the cube root of A8, B31, C, what do you got, Jeff? 22, sure. So let's see, what do I just say to myself? 3 goes into 8. 2 times with? 2 left over. 3 goes into 31. 10 times with? 1 left over. 3 goes into 22. 7 times with? 1 left over. Bam. So you see how I kind of lay a space? I lay a space if I do this problem. All right. Yes. Oh, stretch. So let me come back to this problem. Let's actually do this problem. Let's do a problem that's just like the one we just did, and then we'll build up. Oh yeah, this is where the okay. All right, Jim. So number 9 together. This is page 181. This is this idea by itself. Now, the one extra thing they've thrown in on this is there's a 32 there. But we know how to handle numbers. It's the 4th root of 32. So we just talked about this one. The 1/4 root you should know for sure is 16. Or actually, watch this. Let me do it this way. You ready? Because 32 is 16 times 2, so you could attack it like that. Or, let's rewrite this. 32 is 2 to the 5th, right? We just talked about it a minute ago. There's 5 2's in 32. If I write any number in exponential form, it has to act the same way the variables do. The only reason they act differently is one is in exponent form, the other one isn't. But now they're both in exponent form. So how does the shortcut work? 4 goes into 5. 1. So 1, 2 out here with how many left over? 1. 4 goes into 5 once with 1 left. Oh shit, come out of here. You guys with me? So 4 goes into 5 once, so there's a 2 out here with 1 2 left in. 4 goes into 5 once, so there's 1x with 1 left over. 4 goes into 4 once with none left over. 4 goes into 3? Nope. So all of those get left over. And you know me. All right. So look at the x piece. How would you write this as a fractional power? X to the 5 over 4. What is 5 over 4 as a mixed number? So this is definitely x to the 5 fourths. Is that cool? Roots on the bottom, powers on the top. 5 fourths is what as a mixed number? 1 and 1 and a fourth, right? So I should have a 1x and a fourth of an x in my, shit, I do. All right.
How'd you find the next number?
4 goes into 5 once with 1 left over. So it's 1 and a quarter. Yeah. So I'm not saying you have to look at it that way all of a sudden. I'm saying that's another way to look at why this answer makes sense. Roots are division. That's why division is a shortcut for doing this. They divide into the powers. They cut the powers in that many parts. Right, because I would write that on the bottom of the power. So they're going to cut the powers in that many parts. That's why this shortcut works. Let's see. Okay, this is where they get all the funky fonts. I don't know what that happened is. I'll show you something. Let's go back to this one, where we are now. Number 3 on page 183. That's where we left off. So let me write this in a better form. This is the 4th root of. This is where you start getting used to this. 32 was 2 to the what power? Because 5 2s and 32. So 64 would be 2 to the 6th power, because it's got one more 2. I like it. So let me write everything in exponent form so then I can use that shortcut. So 4 goes into 6 once with 2 left over. 4 goes into 5 once with 1 left over. And on the bottom, 4 goes into 12 3 times with none left over, right? Yes?
Starting at the beginning, did you just break the 64 down into...
Yeah.
But you could do it without having to do that, right?
Totally.
Okay.
Another way to do, anybody have another question? Because I'll do that piece another way. So you always have another option with numbers because you can write them as a number or in exponent form. If I write them in exponent form, the shortcut works. If I left it like this, what could I do? Holy shit, there it is. I can break it down into 4 through to 16 times the 4 through to 4. What's 4 through to 16? 2. 4 through to 4, I don't know. And is that what we got? We got a 2 and a 4th root of, what's this? 4. Yeah. So you can look at it either way. That's the special thing about numbers. Since they are numbers and I know everything about them, I have multiple ways I can write them. If I write it as a power, I could use that same shortcut that I use on variables. If I leave it as a number, I do it the way we did before. I break it up into a part that works and a part that doesn't work, and I do it. Both ways have to agree. Maybe. Of course, this is the part that students really actually hate more than they think they will, is when you have options. Because then you're like, well, which option's better? And then some of you guys do half of one option and half of the other. That never works. Right?
This one is more easy for me.
I love it for you. Yes, so do it this way.
Okay.
And somebody else is gonna be like, I hate that way, let's gross, let me do it this way. So it's just totally up to you, which way you pick. Pick way that makes most sense. If they make equally no amounts of sense, come see me.
The way that I had done the 64 was the way you just showed us.
Yes.
But it left the 4 on the inside, is that,
Yes.
that's okay?
But this is still.
It's just 4, right?
It is 4, yeah. So the next step would be 2x, 4 through to 4x over y cubed.
Oh,
Yeah, because 2 squared is 4. Yeah. I like it. Now, what do you think about number 4? What's got to be true when I'm trying to multiply two radicals? When can I do it? If they have the same root, right? So I can multiply 2 cube roots, I can multiply 2 fourth roots, so forth. Multiplication is division, right? At this level, we should be used to there is no division. There isn't. It's multiplication by the inverse, right? So division doesn't really exist. Oh, well, there it is, right there. But so if multiplication requires the same root, and then I can just attack the insides, same damn thing for division, because division is multiplication. So what can I do? 75 divided by 3 inside of a square root. They both have the same root. I'm allowed to divide the insides. Yeah, square root of 70. What's 75 divided by 3? You got 75 cents, and you got 3 friends. You each get a quarter. Square root of 25. 5. Bam. Oh, look, there's a number that I used earlier. Aw. Well, let's do number 6 first. Number 6. I would give you one with more shit inside to do on your own, but too bad.